Hello, and welcome to Sleepy Lab, a quiet place where the night sky opens gently, where questions drift like clouds, and where sleep finds you softly among the stars. If you've had a long day, or if your thoughts are still turning over the hours behind you, this is a place to let them slow. There's nothing you need to remember here, no test waiting at the end, just the calm, patient movement of the cosmos, unfolding at a pace so gentle it asks nothing of you but to breathe, to listen, and to rest. Tonight we'll wander through something both familiar and strange. The stars above us, not as distant sparks frozen in place, but as travelers on journeys so slow they span lifetimes, centuries, entire ages of human history. We'll explore why the constellations drift, why the sky changes across generations, and why the stars, though they seem still, are always moving. But we'll take our time. There's no hurry. The stars themselves have been drifting for billions of years, and they'll continue long after we close our eyes. So settle in, let your shoulders drop, let your breath deepen, and let the night sky carry you gently into rest. The stars you see tonight are not where they were when your grandparents were young. They are not where they will be when your grandchildren, if you have them, look up in wonder. The sky is always shifting, always drifting, but so slowly that a single human life can barely notice. It is a movement measured not in seconds or minutes, but in generations, in centuries, in the long, quiet turning of the earth and the even slower wandering of the stars themselves. To understand this drift, this ancient and patient motion, we begin not with the stars, but with the ground beneath you, with the earth itself, because the first movement of the stars is not their own, it is ours. Every night the sky seems to wheel above us. The stars rise in the east, arc across the heavens, and set in the west. The constellations rotate around a central point, the North Star in the northern hemisphere, or the empty southern pole below the equator. This motion is so steady, so reliable, that ancient peoples used it to mark time, to navigate oceans, to plant crops and tell stories. But the stars are not moving across the sky each night. We are. The Earth is turning, rotating on its axis once every 24 hours, carrying us with it as it spins through space. This is the motion we call Earth's rotation, and it is the simplest, most immediate cause of the stars' nightly journey across our view. Imagine the Earth as a great spinning sphere, silent and tireless, turning eastward through the darkness. As it turns, the stars appear to slide westward, not because they are moving, but because we are. It is like standing on a slow carousel and watching the world drift past. The world is still. You are the one in motion. But from your perspective, everything else seems to glide. This rotation is so smooth, so constant, that we never feel it. There is no lurch, no tremor, just the quiet spin of a planet in the void, carrying billions of lives through day and night, through light and shadow, in an endless rhythm as old as the Earth itself. And because the Earth rotates, the stars seem to trace circles in the sky. If you were to set up a camera pointed at the North Star, leaving the shutter open for hours, you would see the stars around it drawing arcs, long curved trails of light, all centered on that one still point. That point, Polaris, happens to lie almost directly above Earth's North Pole, so it barely moves at all. It is the anchor, the hub, and everything else wheels around it. But this nightly motion, this rising and setting, is only the surface. Beneath it lies something deeper, something slower, a drift so gradual it takes not hours but thousands of years to notice. The Earth does not simply spin, it wobbles. Like a spinning top that has begun to slow, the Earth's axis does not point in exactly the same direction forever. It shifts, it circles. Slowly, almost imperceptibly, the North Pole traces a great loop in the sky, taking roughly 26,000 years to complete one full cycle. This wobble is called precession, and it changes everything. Right now, the North Pole points toward Polaris. That is why we call it the North Star. But it was not always so. 5,000 years ago, when the pyramids of Egypt were being built, the North Pole pointed toward a different star, Thuban, in the constellation Draco. And in another 13,000 years, the pole will point near Vega, one of the brightest stars in the summer sky. The axis is drifting. The Earth is tracing a slow circle in space, and as it does, the stars seem to shift, not quickly, not noticeably in a single lifetime. But across centuries, the sky changes. Constellations that once rose at certain times of year now rise earlier or later. Stars that were near the horizon climb higher, others that were overhead begin to sink. This is not because the stars themselves have moved much. Most stars are so far away that even their own motion through space takes thousands of years to become visible. No, this drift is ours. It is the wobble of the Earth, the slow circling of our axis, gradually changing our perspective on the heavens. To picture it, imagine standing on a gently rocking boat in the middle of a calm sea. The distant mountains on the horizon do not move. But as the boat sways, your view of them shifts. One moment, a peak lines up with your mast. A moment later, it drifts to the side. The mountains have not moved. You have. The stars are the mountains. The Earth is the boat. And precession is the slow, steady rocking that changes what we see. This wobble is caused by the gravitational pull of the Sun and the Moon on the Earth's equatorial bulge. The Earth is not a perfect sphere. It bulges slightly at the equator, a subtle thickening caused by its own rotation. The Sun and Moon pull on this bulge, trying to align it with their own orbits, and the result is a gentle torque, a twisting force that makes the Earth's axis circle slowly through space. It is a cosmic dance, a gravitational waltz between the Earth, the Moon, and the Sun, played out over millennia. And because of it, the sky we see is not the sky our ancestors saw, and it will not be the sky our descendants will know. The ancient Greeks knew the stars well. They mapped the constellations, named the brightest stars, and used the sky to navigate, to farm, to mark the seasons. They saw the same patterns we see today: Orion, the Hunter, the Big Dipper, the Pleiades. But they saw them in slightly different places. Not by much, not enough to confuse the shapes, but enough that careful observers over centuries began to notice. One of those observers was a Greek astronomer named Hipparchus, who lived more than 2,000 years ago. By comparing his own star charts with those made by astronomers a century and a half before him, he noticed something strange. The position of the stars, relative to the point where the Sun crosses the celestial equator during the spring equinox, had shifted. Not by a lot, just a degree or two. But it was real. It was measurable. He called it the precession of the equinoxes, the slow drift of the sky relative to the seasons. And though he did not know the cause, he had discovered one of the deepest rhythms of the Earth, a cycle so long that no single human life could witness its full turn, but so steady that mathematics could predict it across the ages. Today, we know that the equinoxes, the moments when day and night are equal, shift slowly backward through the zodiac. The Sun, during the spring equinox, used to rise in the constellation Aries. Now it rises in Pisces. In a few hundred years, it will rise in Aquarius. This is the so-called Age of Aquarius, a phrase from astrology, but rooted in the real and patient motion of the Earth's axis. Every year, the equinox arrives about 20 minutes earlier than it would if the Earth's axis were fixed. Over a human lifetime, this adds up to only a few hours, barely noticeable. But over centuries, it accumulates. The calendar drifts, the stars shift, and the sky, though still filled with the same constellations, wears a different face. The ancient Egyptians knew Thuban as their pole star. The sailors of the Mediterranean used it to navigate. But today, Thuban is just another star in Draco, nowhere near the pole. Polaris has taken its place. And in the far future, when Vega becomes the pole star, Polaris will drift away, and a new generation will look up and wonder why their ancestors ever called it the North Star at all. This is the first layer of the star's slow movement. The wobble of the Earth, the precession of the axis, a drift so gradual it unfolds across ages, invisible in the moment, but undeniable across time. But there is more. Because the stars themselves are moving too, not just in appearance, not just because the Earth wobbles, but truly, actually, moving through space. Each star is on its own journey, traveling through the galaxy at speeds we can barely imagine, and yet, from our distant perspective, seeming almost still. The stars do not sit still. They never have. Each one is a traveler moving through the vast ocean of space at speeds that would dwarf anything we know on Earth. Some glide at tens of kilometers per second, others race at hundreds. And yet, from where we stand, they seem frozen, pinned to the sky like lights on a distant ceiling. This is because of distance. The stars are so far away that even their tremendous speeds translate into almost no visible motion across our lifetimes. To understand this, imagine watching a distant airplane flying across the horizon. It moves quickly, but because it is far away, it seems to crawl. Now imagine that airplane is 1,000,000 times farther. It would seem motionless, even though it is still flying at the same speed. The stars are like that airplane, only the distances are not millions of times greater. They are trillions of times greater. The nearest star to our Sun, Proxima Centauri, is about 4 light years away. That means the light we see from it tonight left that star 4 years ago. And if Proxima Centauri were moving directly toward us or away from us at a speed of, say, 50 kilometers per second, which is not unusual for a star, it would still take tens of thousands of years for it to appear noticeably closer or farther in the sky. This kind of motion, the motion of a star across our line of sight, is called proper motion. It is the star's movement through space as we see it projected against the background of even more distant stars. And for most stars, this proper motion is incredibly small, a fraction of a degree per century, sometimes less. The fastest moving star visible to the naked eye is Arcturus, a bright orange giant in the constellation Boots. It is racing through space at more than 100 kilometers per second relative to the Sun. But even Arcturus, moving at that speed, takes thousands of years to shift noticeably against the backdrop of the sky. If you could watch the sky for 10,000 years, you would see Arcturus drift slowly from one part of Boots to another, and eventually leave the constellation entirely. But in a single human lifetime, it barely moves at all. Most stars move even more slowly than that. The stars of the Big Dipper, for instance, are drifting in different directions at different speeds. Over the course of 100,000 years, the Big Dipper will no longer look like a dipper. Its stars will spread apart, their paths diverging, and the shape we know will dissolve into something unrecognizable. Tonight, and tomorrow night, and for thousands of nights to come, the Big Dipper will look exactly as it does now. This is the paradox of the stars. They are moving, truly and constantly moving, but the sky changes so slowly that it feels eternal. The constellations we see tonight are the same constellations seen by ancient Babylonians, by Chinese astronomers, by the builders of Stonehenge, the same patterns of light that guided sailors across dark seas and shepherds across open plains. And yet, if we could speed up time, if we could watch the sky across tens of thousands of years, we would see the stars drifting like slow currents in a river. Some moving toward us, others moving away, some rising higher in the sky, others sinking toward the horizon. The constellations would shift, stretch, and eventually break apart, their stars scattering across the heavens in new and unfamiliar patterns. But we cannot speed up time. We can only watch the sky as it is, night after night, year after year, seeing the stars in their ancient places, feeling the weight of their stillness, their quiet endurance. There is something deeply calming in this. The stars move, yes, but they move on timescales far longer than our own. They do not rush. They do not hurry. They simply exist, drifting through space with a patience that makes our own brief lives feel like a single breath in a much longer story. To lie beneath the stars and know this, to feel the slow turning of the Earth and the even slower drift of the stars themselves, is to be held by something vast and gentle. The sky does not change in a way that matters to us tonight. It will not change tomorrow night either. And in that constancy, there is peace. The stars we see are not alone in their motion. They are part of something much larger. They belong to the Milky Way, our galaxy, a great spiral of hundreds of billions of stars, all orbiting a common center. The stars move not just on their own individual paths, but also in the great sweeping motion of the galaxy itself. Our Sun, and all the stars near it, orbit the center of the Milky Way at a speed of about 220 kilometers per second. That is more than 800,000 kilometers per hour. And yet, the orbit is so large, so immense, that it takes the Sun roughly 230 million years to complete one full lap around the galaxy. This is called a galactic year, and in the time since the dinosaurs first appeared on Earth, the Sun has completed only about one galactic year. The stars around us are all on similar orbits, but not identical. Some move a little faster, some move a little slower. Some have orbits that tilt up out of the galactic plane, others dip below it. Over time, stars that are close together now will drift apart, and stars that are far apart will slowly come closer. It is a slow churn, a gradual mixing, as the galaxy rotates and its stars weave through space. This galactic motion does not change the constellations in our lifetime, or even in 1,000 lifetimes. But over millions of years, it too contributes to the drift. Stars that are near the Sun today will eventually wander far from us, and new stars will drift into our neighborhood, bringing with them new lights and new patterns in the sky. The stars, then, are not just moving through space, they are moving through time, through the vast, patient time of the galaxy, where 1,000,000 years is a brief moment, and the lifetime of a star can stretch for billions of years. To think of this is to feel the weight of deep time, the kind of time that does not belong to clocks or calendars, but to geology, to evolution, to the slow turning of galaxies and the birth and death of suns. It is time on a scale so large it becomes abstract, almost dreamlike, and yet it is real. It is the time in which the stars live, the time in which the constellations drift. And we, tiny and brief as we are here to witness it. Not all of it, just this one fleeting moment, this one configuration of stars, this one view of the sky. But that is enough. There is another motion, quieter still, that affects how we see the stars. It is the motion of the Sun itself through space, carrying the entire solar system with it. The Sun is not fixed in one place within the galaxy. It is moving, traveling through the local neighborhood of stars at about 20 kilometers per second toward a point in the constellation Hercules. This point is called the solar apex, and it is the direction we are heading as we orbit the galaxy. As the Sun moves, the stars around us appear to shift very slightly. Stars in the direction we are moving seem to spread apart, as if we are flying toward them and they are scattering to make way. Stars behind us, in the direction we are leaving, seem to draw together, as if closing the door behind us. This effect is called solar motion, and it is one more thread in the slow weaving of the sky's appearance. But again, the effect is tiny, imperceptible in a single lifetime. It takes thousands of years for the solar apex to shift the stars in any noticeable way, and by the time it does, other motions, precession, the proper motion of individual stars, have also changed the sky, so it is hard to separate one effect from another. All these motions layer together: the rotation of the Earth, the wobble of its axis, the motion of individual stars, the orbit of the Sun around the galaxy. Each one contributes to the slow drift of the constellations, the patient changing of the sky, and none of them can be noticed in a single glance, or even in a single year. They require patience, memory, the long view of history. Ancient astronomers did not have telescopes or computers. They had only their eyes, their careful records, and the slow passage of time. And yet, they noticed. They saw that the sky was not perfectly still, that the stars, though they seemed eternal, were drifting, that the pole star changed, that the equinoxes shifted. They did not have the full explanation, but they saw the evidence, and they wondered. Hipparchus, the Greek astronomer, was one of the first to measure precession, but he was not the only one who noticed. Ancient Chinese astronomers also kept careful records of the stars, and they too noted shifts over time. In India, astronomers studied the slow movement of the equinoxes and incorporated it into their calendars. These were cultures separated by thousands of kilometers, yet they all saw the same thing. The sky was drifting, slowly, quietly, but undeniably. Today, we can measure these motions with extraordinary precision. We have satellites that track the positions of stars to within tiny fractions of a degree. We have computers that can simulate the sky thousands of years into the past or future, showing us what the constellations looked like to ancient peoples, or what they will look like to those who come after us. We can map the motion of every star in our neighborhood, tracing their paths through the galaxy, predicting where they will be in a million years. But even with all that knowledge, the experience of the night sky remains the same. When you lie beneath the stars, they do not feel like they are moving. They feel still, eternal, unchanging. And in a way, they are. Because the motion is so slow, so patient, that it exists on a timescale beyond our perception. It is there, always there, but it does not intrude. It does not demand to be noticed. And perhaps that is part of the beauty. The stars are both constant and drifting, both eternal and fleeting. They are the same stars seen by ancient peoples, and yet they are not quite the same. They have drifted, we have drifted. And the sky we share with the past and the future is always changing, always the same. There is something about the stillness of the stars that invites us to imagine them as fixed, as though they have always been where they are and always will be. The ancients certainly thought this. Many early astronomers believed the stars were embedded in a great crystal sphere that rotated around the Earth, carrying the stars with it. They were called the fixed stars, to distinguish them from the planets, which clearly wandered across the sky. But the stars are not fixed. They only seem that way because we are small and they are far, and time for us moves quickly. If you could watch the sky for 1,000 years, you would begin to see the drift. If you could watch for 10,000, you would see constellations change shape. If you could watch for 100,000, the sky would become unrecognizable, filled with new patterns, new arrangements, the old shapes dissolved into something entirely different. But we cannot watch for that long. We have only our brief lives, and in that time the stars do not move enough for us to see. So we see them as they are, suspended in their ancient places, and we call them eternal. Yet they are not eternal. They are moving, always moving, just very, very slowly. Consider Polaris, the North Star. Right now it sits almost directly above the Earth's North Pole, and for that reason it has been used for navigation for centuries. Sailors crossing dark oceans could look up and find Polaris, and know which way was north. Travelers crossing deserts or mountains used it to orient themselves. It was a constant, a guide, a light that did not move. But Polaris has not always been the North Star, and it will not always be. 5,000 years ago, the pole pointed toward Thuban, a dimmer star in the constellation Draco. Thuban was the North Star when the pyramids were built. Ancient Egyptians aligned some of their structures with Thuban, using its position to mark north with extraordinary precision. To them, Thuban was the anchor of the sky, the still point around which all other stars revolved. But the Earth's axis wobbled, the pole drifted, and Thuban slowly moved away from the pole, no longer marking north. For a time, there was no bright star near the pole. The northern sky simply turned around an empty point, a dark center with no guide star. Then, over centuries, Polaris drifted closer. By the time of the Middle Ages, it had become the new North Star, and it has held that position ever since. But it will not hold it forever. In about 12,000 years, the pole will point toward Vega, a brilliant blue-white star in the constellation Lyra. Vega will become the North Star, and it will be far brighter than Polaris, outshining it easily. Future peoples will look up and see Vega as their anchor, their guide, and they will wonder why ancient texts spoke of Polaris as though it was special. And then, thousands of years after that, the pole will drift again, moving past Vega, and eventually returning toward Polaris once more. The cycle will complete. The great wheel of precession will turn full circle, and Polaris will return to its place near the pole. This is the rhythm of precession, a 26,000-year cycle, slow and patient, changing the sky in ways too gradual to see, but profound across the ages. The pole star changes, the equinoxes shift, the constellations drift, and the sky, though it looks the same tonight as it did last night, is always moving. There is a calmness in knowing this. The sky is not frozen. It is alive with motion, but motion so slow it feels like stillness. It is change without urgency, drift without haste. The stars move, but they do so at a pace that asks nothing of us. We do not need to watch, we do not need to track their motion. We can simply lie beneath them and rest, knowing they are there, steady and patient, even as they drift. The constellations too are drifting. Not as single points, but as patterns made of many stars, and each star moves on its own path. Over time, the shapes we know will change. The stars that form the Big Dipper, for instance, are not all moving in the same direction. Some are moving toward us, some are moving away, some are drifting left, others right. Right now, the Big Dipper looks like a dipper, a cup with a handle, clear and recognizable. But 100,000 years ago, it did not look quite the same. The handle was straighter, the cup was more elongated. If you could go back in time and show an ancient person the shape of the Big Dipper as it appears today, they would recognize it, but they would also notice the differences. And 100,000 years from now, the Big Dipper will look different again. The stars will have drifted farther. The handle will bend in a new direction. The cup will stretch and warp. Eventually, it will no longer look like a dipper at all. It will be a new shape, and future peoples will give it a new name, or perhaps forget it entirely, as other brighter patterns take its place. This is happening to all the constellations. Orion, the great hunter, will slowly distort. His belt, the 3 bright stars in a row, will spread apart. His shoulders and feet will drift. In 1,000,000 years, Orion will be unrecognizable. The pattern we have known for thousands of years will dissolve into the random scattering of stars, and new patterns will emerge in its place. But again, this happens so slowly that it does not matter to us tonight. Orion is still Orion. The Big Dipper is still the Big Dipper. The constellations are the same as they were when we were children, and they will be the same when our children look up. The stars do not rush, they do not hurry to change. They simply exist, drifting gently through the galaxy, and we, in our brief moment, witness them as they are. There is a deeper rhythm beneath all this. A rhythm that connects the motion of the stars to the motion of the Earth, and both to the slow turning of the seasons. This is the rhythm of the equinoxes and solstices, the moments when the sun reaches its highest and lowest points in the sky, or crosses the celestial equator. The equinoxes mark the times when day and night are equal. The spring equinox around March 20th and the autumn equinox around September 22nd. The solstices mark the longest and shortest days of the year. The summer solstice around June 21st and the winter solstice around December 21st. These dates are not fixed to the stars. They are fixed to the Earth's orbit around the sun. But because of precession, the stars that appear behind the sun during these moments change over time. Right now, the sun crosses the celestial equator during the spring equinox while it is in the constellation Pisces. But 2,000 years ago, it was in Aries. And 2,000 years from now, it will be in Aquarius. This is why astrology, which is based on the positions of the sun relative to the constellations, no longer aligns with the actual sky. When astrology was codified, the spring equinox occurred when the sun was in Aries. But precession has shifted the sky since then, and now the sun is in Pisces during the spring equinox. The constellations have drifted, but the astrological signs have not moved with them. They remain tied to the ancient positions, fixed in time. This drift, this slow slipping of the seasons relative to the stars, is called the precession of the equinoxes. It is one of the most profound effects of the Earth's wobble, and it has been known since ancient times. Hipparchus discovered it by comparing the positions of stars during the equinoxes with records made by earlier astronomers. He saw that the stars had shifted very slightly, and he realized that the Earth's axis must be moving. Today we measure this shift with incredible precision. The equinoxes precess at a rate of about 50 arcseconds per year. That is a tiny angle, about 1/50th of a degree. But over centuries, it adds up. Over the 26,000-year cycle of precession, the equinoxes shift all the way around the sky, moving through all 12 constellations of the zodiac. This has practical effects, even today. Our calendar, the Gregorian calendar, is designed to keep the equinoxes and solstices aligned with specific dates. But because of precession, the calendar has to be adjusted very slightly over long periods of time. Leap years help, but they are not perfect. Every few thousand years, small corrections are needed to keep the calendar in sync with the seasons. But for most of us, these adjustments are invisible. The seasons come and go as they always have. Spring follows winter, summer follows spring. The rhythm of the year feels constant, eternal, even though beneath it, the earth is wobbling and the stars are drifting. There is a question that ancient peoples must have asked as they watched the stars night after night, season after season. Why does the sky turn? Why do the stars rise and set? Why does the sun move across the heavens? For a long time, the answer seemed obvious. The earth was still, and the sky moved. The stars were attached to a great sphere, a celestial sphere, that rotated around the earth once every day. This was the geocentric model, and it made sense. It matched what people saw. It explained the motion of the stars, the rising and setting of the sun, the slow drift of the planets. But there were problems. The planets did not move smoothly across the sky. They wandered. Sometimes they moved forward, sometimes they stopped, sometimes they even moved backward. This was called retrograde motion, and it was difficult to explain with a simple rotating sphere. Astronomers tried to solve this by adding more spheres. Spheres within spheres, each one rotating at a different speed, each one carrying a planet or the sun or the moon. The models became more and more complex, with dozens of spheres all nested together, all rotating in perfect harmony. And yet, the models never quite worked. The planets still moved in ways that did not fit. The predictions were always a little off. Then, in the 16th century, a Polish astronomer named Nicolaus Copernicus proposed a radical idea. What if the Earth was not the center? What if the Earth was moving, not the sky? What if the stars only seemed to move because the Earth was rotating? It was a simple idea, but it turned the entire universe upside down. If the Earth was rotating, then the stars did not need to be on a moving sphere. They could be far away, scattered through space, and their apparent motion would simply be an effect of the Earth's spin. The rising and setting of the stars, the nightly turning of the sky, all of it could be explained by a single motion: the rotation of the Earth. At first, people resisted. It did not feel like the Earth was moving. There was no wind, no sensation of motion. How could the Earth be spinning without us feeling it? And if the Earth was moving, why didn't everything fly off into space? But over time, the evidence mounted. Copernicus's model explained the retrograde motion of the planets. It simplified the orbits. It made predictions that matched observations. And eventually, with the work of Galileo, Kepler, and Newton, the heliocentric model, the model with the sun at the center and the Earth moving around it, became accepted. The Earth was not still. It was spinning, rotating once every 24 hours. And the stars, those distant lights, were not moving across the sky. They were simply there, far away, while we turned beneath them. This realization changed everything. It changed how we understood the universe. It changed our place in it. We were no longer the center. We were no longer still. We were on a small, spinning planet orbiting an ordinary star, in a galaxy filled with billions of other stars. And yet, the sky still looked the same. The stars still rose and set. The constellations still wheeled overhead. The motion was still there, just as it had always been. Only now we understood it differently. We understood that the motion was ours. The Earth rotates smoothly, at a constant speed of about 1,600 kilometers per hour at the equator. But we do not feel it, because we are moving with it. Everything on the Earth's surface, the air, the oceans, the mountains, all of it rotates together, so there is no relative motion. It is like sitting in a car moving at a constant speed on a smooth road. If you close your eyes, you cannot tell you are moving. But if you watch the world outside, you see it passing by. the trees, the buildings, the horizon. They all seem to move, even though you are the one in motion. The stars are the same. They seem to move because we are rotating. And because we rotate smoothly and constantly, the stars move smoothly and constantly across the sky. They rise in the east, where the Earth is turning toward them. They set in the west, where the Earth is turning away. And they trace long arcs across the sky, higher near the middle of the night, lower near dawn and dusk. Near the poles, the motion is different. At the North Pole, the stars do not rise or set. They simply circle around Polaris, the North Star, in endless loops. Stars near Polaris never dip below the horizon. They are always visible, circling night after night, tracing the same paths. At the equator, the motion is more dramatic. The stars rise almost straight up from the horizon, arc high overhead, and set almost straight down. The motion is faster, more obvious. The entire sky seems to rotate around you. Between the poles and the equator, the motion is somewhere in between. Stars rise at an angle, arc across the sky, and set at an angle. Some stars, near the celestial pole, circle without setting. Others, near the celestial equator, spend half their time above the horizon and half below. This motion, this daily turning of the sky, is the most immediate and obvious motion we see. It is the motion that ancient peoples used to tell time, to navigate, to mark the passage of the night, and it is entirely an effect of the Earth's rotation. The stars themselves are not moving, we are. But the Earth's rotation is not the only motion that affects how we see the stars. There is also the Earth's orbit around the Sun. As the Earth moves through its orbit, the position of the Sun against the background stars changes. Over the course of a year, the Sun appears to move through the 12 constellations of the zodiac, spending about a month in each one. This motion is called the ecliptic, the path the Sun traces across the sky. And because the Sun is so bright, we cannot see the stars near it. During the day, the Sun's light drowns out the stars, but at night we can see the stars on the opposite side of the sky, the stars that are far from the Sun. This means that the stars we see at night change over the course of the year. In winter, we see one set of constellations. In summer, we see a different set. The sky rotates not just over the course of a single night, but also over the course of the year, as the Earth moves around the Sun and our view of the stars shifts. The stars we see in January are not the same as the stars we see in July. Orion, the great winter constellation, is high in the sky on January nights, but invisible in July, hidden behind the Sun. Scorpius, the summer constellation, is high in the sky on July nights, but invisible in January, again hidden behind the Sun. This annual cycle is another rhythm, slower than the daily rotation, but still regular and predictable. It is the rhythm of the seasons, the rhythm of the Earth's orbit, and it shapes the sky in a different way than the rotation does. And beneath both of these motions, the daily rotation and the annual orbit, there is the even slower motion of precession, the wobble of the Earth's axis, changing the position of the pole star, shifting the equinoxes, drifting the constellations over thousands of years. All these motions layer together. The Earth spins, the Earth orbits, the Earth wobbles, and the stars, distant and patient, seem to move in response, even though they are not moving at all. Or rather, they are moving, but so slowly, so far away, that their motion is invisible compared to ours. To lie beneath the stars and know this is to feel the layered rhythms of the cosmos. The fast rhythm of the Earth's rotation carrying the stars across the sky each night. The slower rhythm of the Earth's orbit, changing the stars we see with the seasons. And the slowest rhythm of all, the wobble of the axis drifting the sky across millennia. Each rhythm has its own pace, its own time scale, and together they create the motion we see, the rising and setting, the seasonal changes, the long drift of the constellations. But all of it, every motion, every shift, happens so smoothly, so gently, that it never feels rushed. The sky does not hurry, the Earth does not lurch. Everything moves with a quiet grace, a patient turning, a rhythm as old as the planet itself. And we, lying beneath it all, are carried along, spinning with the Earth, orbiting with the sun, drifting with the slow wobble of the axis. We are part of the motion, even when we are still. The stars have always been guides, not just for navigation but for time itself. Before clocks, before calendars, there were the stars, rising and setting, appearing and disappearing with the seasons, marking the passage of hours, days, months, and years. Ancient peoples watched the stars carefully. They noticed which stars rose just before the sun at certain times of year, a phenomenon called heliacal rising. They used these risings to mark the seasons, to know when to plant crops, when to expect floods, when to prepare for winter. In ancient Egypt, the heliacal rising of Sirius, the brightest star in the sky, signaled the annual flooding of the Nile. Every year, around the middle of summer, Sirius would appear in the eastern sky just before dawn, rising above the horizon for the first time after being hidden behind the sun for months. And every year, within days of that rising, the Nile would begin to flood, bringing water and fertile soil to the fields. The Egyptians called Sirius the Nile Star, and they watched for it with great care. Its rising marked the beginning of their new year, the start of a new cycle of growth and harvest. It was a clock written in the sky, reliable and precise. Other cultures had their own celestial markers. The ancient Greeks used the rising of the Pleiades, a small cluster of stars, to mark the beginning of spring planting. Farmers would watch for the Pleiades to rise in the early morning sky, and when they did, it was time to prepare the fields. In the Pacific, Polynesian navigators used the stars to cross vast stretches of ocean, traveling thousands of kilometers without maps or compasses. They memorized the rising and setting points of dozens of stars and used them to steer their canoes across open water, navigating by the slow, steady turning of the sky. The stars were not just lights, they were a language, a calendar, a map. They told stories, yes, but they also told time. They marked the seasons. They guided travelers. They connected the rhythms of the earth to the rhythms of the heavens. And all of this was possible because the stars moved, or seemed to move, in predictable ways. The same stars rose at the same times every year. The same constellations appeared in the same seasons. The sky was a clock, and anyone who learned to read it could tell time, not in minutes or seconds, but in the long, slow cycles of the earth and the stars. But the sky was not perfectly predictable. Over long periods, the ancient astronomers began to notice small shifts. The stars did not rise at exactly the same times every year. The equinoxes drifted, the constellations changed position. These shifts were tiny, almost imperceptible, but they were real. Hipparchus, the Greek astronomer, noticed this when he compared his own observations with those made a century and a half earlier. The spring equinox had shifted. The sun no longer crossed the celestial equator at the same point among the stars. It had drifted backward, moving slowly through the zodiac. He did not know why this was happening, but he measured it. He calculated the rate of drift and found that it was about 1 degree every 72 years. That is incredibly slow. In a single human lifetime, the shift is barely noticeable, but over centuries it adds up. Over millennia, it changes the sky. Today, we know that this drift is caused by precession, the wobble of the Earth's axis. But to Hipparchus, it was simply a mystery, a slow drift in the fabric of the heavens, a sign that the stars, though they seemed eternal, were not quite fixed. Other ancient astronomers noticed similar things. In India, astronomers studying the positions of the sun and moon relative to the stars found that the calendar drifted over time. The dates of the solstices and equinoxes slowly shifted relative to the stars. They incorporated this drift into their astronomical tables, creating complex systems to account for it. In China, astronomers kept meticulous records of the positions of stars and planets over centuries. They noticed that the pole star changed over time, that the stars near the pole drifted, and that the sky, though it seemed stable, was actually in slow motion. These observations, made independently by cultures separated by thousands of kilometers, all pointed to the same truth. The sky was not fixed, it was drifting, slowly, patiently, but undeniably. And yet for most people, this drift did not matter. The stars still rose and set, the seasons still came and went, The sky still looked the same night after night, year after year. The drift was too slow to see, too gradual to feel. It existed only in the careful records of astronomers, in the slow accumulation of measurements over generations. Today, we can measure the positions of stars with incredible precision. We have satellites that track the motion of the Earth and the stars to within fractions of a degree. We have atomic clocks that measure time to within billionths of a second. And we have computers that can simulate the sky thousands of years into the past or future, showing us exactly how the constellations have changed and will change. But even with all this technology, the experience of the night sky remains the same. When you lie beneath the stars, they do not feel like they are moving. They feel eternal, unchanging, constant, and in a way they are. Because the motion is so slow that it exists on a timescale beyond our perception. The stars drift, yes, but they drift so gently that it does not intrude on the present moment. It does not demand to be noticed. It simply is. This is part of the beauty of the stars. They are both constant and changing, both still and moving. They are the same stars that ancient peoples saw, and yet they are not quite the same. They have drifted, we have drifted. And the sky we share with the past and the future is always changing, always the same. To know this is to feel the depth of time, not the shallow time of days and weeks, but the deep time of millennia and ages. The time in which mountains rise and erode, the time in which species evolve and go extinct, the time in which the stars drift across the sky so slowly that a single human life is just a heartbeat, a single breath in the long story of the cosmos. And yet we are here, in this moment, beneath these stars, watching them as they are, not as they were or will be, but as they are right now, still, quiet, glowing softly in the dark. The Earth turns beneath us, the axis wobbles, the stars drift, and we rest, held by the slow, patient motion of it all, carried gently through the night. The night sky holds a kind of memory, not in the way we remember things, with thoughts and images, but in the way a river remembers its course, or a tree remembers the seasons. The stars we see tonight are arranged in patterns that have been visible for thousands of years. And though they are drifting, though they are slowly changing, they carry with them the shape of the past. When you look up at Orion the Hunter, you are seeing the same pattern that ancient peoples saw. The 3 stars of his belt, aligned almost perfectly in a row. The bright stars marking his shoulders and feet. The sword hanging from his belt, glowing faintly in the darkness. This is the same Orion that guided sailors across the Mediterranean, that marked the winter season for farmers, that appeared in myths and stories across dozens of cultures. The pattern has not changed, not in any way that matters to us. The stars are in the same places relative to each other as they were 1,000 years ago, 5,000 years ago. The drift is there, yes, but it is so small, so gradual, that Orion remains Orion. The hunter is still the hunter, and this constancy is comforting. In a world that changes quickly, where technology reshapes our lives every few years, where cities grow and forests vanish, where nothing seems to stay the same for long, the stars remain. They are a kind of anchor, a reminder that some things move slowly, that some rhythms are longer than a single human life, that the universe operates on timescales that make our own hurried lives feel brief and fleeting. To lie beneath Orion and know that this is the same pattern seen by people thousands of years ago, people who lived lives so different from ours, who spoke different languages, believed different things, faced different challenges, and yet looked up and saw the same stars, is to feel a connection across time. A thread that links us to the past and to the future. Because the same Orion we see tonight will be visible, largely unchanged, for thousands of years to come. Our descendants, if they look up, will see the same hunter, the same belt, the same sword. This is the gift of the slow drift. The constellations change, yes, but they change so slowly that they span generations, civilizations, entire eras of human history. They are both ancient and present, both eternal and fleeting. The stars are not just points of light, they are distances made visible. When you look at a star, you are not seeing it as it is now. You are seeing it as it was when the light left it, years or decades or centuries ago. The light from the nearest stars takes about 4 years to reach us. The light from more distant stars takes hundreds or thousands of years. And the light from the farthest stars we can see with the naked eye, dim stars on the edge of visibility, may have been traveling for thousands of years before it reached your eyes tonight. This means that the night sky is a kind of time machine, not in the sense of traveling through time, but in the sense of seeing the past. When you look at the stars, you are looking backward in time, seeing the universe not as it is now, but as it was. The stars you see tonight are ghosts, echoes of light from suns that may have changed, or even died, in the time it took their light to reach you. Betelgeuse, the bright red star marking Orion's shoulder, is a good example. It is about 650 light-years away, which means the light we see from it tonight left that star 650 years ago. In the 1370s, long before telescopes, long before we understood what stars were. And Betelgeuse is a dying star, a red supergiant that will one day explode as a supernova. When it does, it will briefly outshine every other star in the sky, visible even during the day. But if Betelgeuse exploded yesterday, or last year, or 100 years ago, we would not know yet. The light from that explosion would still be traveling toward us, crossing the vast distance of space, and we would not see it until it arrived. We see Betelgeuse not as it is, but as it was, a ghost from the past, still glowing in the present. This is true of all the stars. Every point of light in the night sky is a messenger from the past carrying information about a distant place, a distant time. The farther the star, the older the message. The nearer the star, the more recent the light. And because the stars are moving, drifting through space on their own journeys, the light we see tonight was emitted from a slightly different place than where the star is now. The star has moved in the time it took the light to reach us, though usually not by much. The motion is small, the distances are vast, and the light travels so quickly that the difference is usually negligible, but it is there. The stars we see are not quite where they appear to be. They are slightly ahead or slightly behind, depending on their motion relative to us. This makes the night sky not just a map of space, but a map of space-time. A view that combines both distance and time, showing us the universe not as a single frozen moment, but as a layered history, with each star at a different point in the past. To think about this is to feel the strangeness of light. Light moves quickly, the fastest thing in the universe, crossing nearly 300,000 kilometers every second. And yet, the universe is so vast that even light takes time to cross it. Years, centuries, millennia. The stars are so far away that their light, though it moves without pause, without rest, still takes lifetimes to reach us. And in that time, the universe changes. The star that emitted the light may have moved, it may have aged, it may have died. But the light continues carrying the image of the star as it was, not as it is. And when that light finally reaches us, we see the past, we see a moment that no longer exists, preserved in the light that has been traveling toward us all this time. This is why the stars seem so still, not just because they are far away, but because we are seeing them in the past. The motion they make takes time to become visible, time for the light to cross the distance and bring us the new image. By the time we see a star move, it has already moved. The motion we see is delayed, stretched out by the time it takes light to travel. And this delay, this lag between the star's motion and our perception of it, is part of what makes the sky feel eternal. The stars do not rush because we see them in slow motion, their movements stretched across time, visible only in the careful records of astronomers who compare observations made decades or centuries apart. There is a rhythm to the way we see the stars, a rhythm shaped by the speed of light and the vastness of space. It is a slow rhythm, patient and unhurried, and it shapes our experience of the night sky in ways we rarely think about. The stars are not just far away, they are distant in time as well. And that distance softens their motion, makes it gentle, makes it feel like stillness. The Earth's axis wobbles, and this wobble, this precession, is not random. it has a cause, and that cause is gravity. The gravitational pull of the sun and the moon on the Earth's equatorial bulge creates a torque, a twisting force, that makes the axis circle slowly through space. To understand this, imagine a spinning top. When a top spins upright, perfectly balanced, its axis stays still. But as it begins to slow, as friction and gravity pull on it, the axis starts to wobble. It traces a cone in the air, circling around the vertical, but never quite pointing straight up or straight down. This wobble is called precession, and it is the same thing that happens to the Earth. The Earth is not a perfect sphere. It bulges at the equator, a subtle thickening caused by its rotation. The equator is about 43 kilometers wider in diameter than the poles, a small difference on a planet that is nearly 13,000 kilometers across, but enough to matter. The sun and moon pull on this bulge, trying to align it with their own orbits, and the result is a gentle torque that makes the Earth's axis wobble. This wobble is very slow. The axis traces a circle in the sky, but it takes about 26,000 years to complete one full loop. That is roughly 1 degree every 72 years, or about 50 arc-seconds per year. A tiny amount, imperceptible in a single lifetime, but measurable over centuries. The wobble is also very smooth. There are no sudden jerks, no abrupt changes. The axis moves steadily, constantly, tracing its slow circle through the sky with the patience of a planet that has been spinning for more than 4 billion years. And this wobble, this precession, is what causes the long drift of the constellations, the slow change in the pole star, the gradual shift of the equinoxes. It is the deepest rhythm in the motion of the stars, the slowest cycle, the one that takes not days or years but millennia to complete. To feel this rhythm is to touch deep time, the kind of time that does not fit in a human lifespan, that stretches across generations, across entire civilizations. It is the time in which languages evolve and die, in which forests turn to deserts and deserts turn to oceans, in which the surface of the Earth itself changes shape. And yet it is real. It is happening right now as you lie beneath the stars. The Earth is wobbling very slowly, and the pole is drifting very gradually, and the sky is changing bit by bit, night by night, year by year. You cannot see it, you cannot feel it, but it is there, a slow current beneath the stillness, shaping the sky across the ages. There are other forces at play as well, smaller wobbles, minor variations in the Earth's rotation and orbit. The Earth's axis does not just precess, it also nutates, a small nodding motion superimposed on the larger wobble. Nutation is caused by the changing positions of the moon and sun relative to the Earth, and it creates tiny shifts in the axis, back and forth, over periods of weeks or months. These shifts are even smaller than precession, measured in fractions of an arc-second, and they have almost no effect on the appearance of the sky over human timescales. But they are there, another layer of motion, another ripple in the slow dance of the Earth and the heavens. The Earth's orbit around the sun also changes very slowly. The shape of the orbit, how elliptical it is, shifts over tens of thousands of years. The tilt of the Earth's axis, which determines the severity of the seasons, also varies slightly, increasing and decreasing over a cycle of about 41,000 years. And the timing of the equinoxes and solstices relative to the Earth's closest and farthest points from the sun changes as well, in a cycle called the precession of the perihelion, which takes about 23,000 years. All of these cycles, these slow variations in the Earth's motion, are called Milankovitch cycles, named after the Serbian scientist who studied them in the early 20th century. They affect the amount of sunlight the Earth receives at different latitudes and different times of year, and they are thought to play a role in the timing of ice ages, the slow advance and retreat of glaciers over tens of thousands of years. But for the stars, these cycles are just more layers of motion, more rhythms stacked on top of each other. The Earth spins, the Earth orbits, the Earth wobbles, the orbit changes shape, the tilt varies. And all of these motions combine to create the slow drift of the constellations, the patient changing of the sky. To know this is to see the night sky not as a single thing, but as a symphony, a layered composition of many rhythms, some fast, some slow, all playing together, all shaping what we see. The stars rise and set with the Earth's rotation. They change with the seasons as the Earth orbits the Sun. They drift across millennia with the wobble of the axis. And beneath all of it, the stars themselves are moving, though so slowly, so far away, that their motion is almost invisible. Every motion has its time scale, every rhythm has its pace. And together they create the experience of the night sky, the sense of both stillness and motion, both constancy and change. There is a star that ancient peoples used to navigate, and it is not the one we use today. Long before Polaris became the North Star, before it drifted into position above the pole, sailors and travelers looked to other lights for guidance. And long after Polaris has drifted away, future peoples will look to different stars, different guides, and they will wonder at the records we left behind, records that speak of Polaris as though it were fixed in place. The sky is not a fixed map. It is a living document, constantly rewriting itself, though so slowly that we can barely see the changes. The pole star changes, the shapes of constellations shift, the positions of the equinoxes drift. And all of this is part of the natural rhythm of the Earth and the stars, a rhythm that plays out over timescales longer than empires, longer than languages, longer than most of what we think of as permanent. In ancient China, astronomers recorded the positions of stars with great care, and they noticed something that puzzled them. The stars near the pole were not quite where earlier records said they should be. Over centuries, the pole had drifted, and the stars that once circled close to it had moved away, while new stars had drifted closer. They did not have the full explanation for this. They did not know about precession or the wobble of the Earth's axis. But they saw the effect, and they recorded it, and their records have helped modern astronomers trace the motion of the pole across thousands of years. In ancient Greece, Hipparchus made similar observations, and he was the first to propose that the axis of the Earth might be moving. He calculated the rate of drift, measured in degrees per century, and though he did not know the cause, he understood that the sky was changing, slowly and steadily, in ways that could be measured and predicted. Today, we can trace the motion of the pole backward and forward in time with great precision. We know that 5,000 years ago, the pole pointed toward Thuban. We know that in 12,000 years it will point toward Vega. We can map the entire cycle of precession, the full 26,000-year loop, and we can see how the pole has wandered across the sky, and how it will wander in the future. But even with all this knowledge, the experience of the night sky remains deeply human. When you look up at Polaris, you are not thinking about Thuban or Vega. You are seeing the North Star, the guide, the light that marks north. And it feels fixed, it feels eternal, because in your lifetime, and in the lifetimes of everyone you know, it has not moved. It is still the North Star. It is still the anchor. And that is enough, because the slow drift of the sky, though it is real, though it is measurable, does not intrude on the present moment. It exists in the background, in the deep time beneath the surface, and it does not ask to be noticed. It simply is. There is a beauty in this. The stars are both ancient and present, both changing and constant. They drift, but they drift so slowly that they feel eternal, and we, in our brief moment beneath them, can rest in their constancy, knowing that they have been here before us and will be here after us, glowing softly in the dark. The ancient astronomers did not have telescopes. They did not have computers or satellites or atomic clocks. They had only their eyes, their careful records, and the slow passage of time. And yet, they saw the motion of the sky. They measured it, they predicted it. They understood in their own way that the heavens were not fixed but slowly turning, slowly changing. This is a testament to patience, to the willingness to watch the sky night after night, year after year, generation after generation, and to compare what is seen with what was seen before. It is a kind of science that requires not just intelligence but time, the time to let the universe reveal itself at its own pace. We live in an age where we expect answers quickly. where questions can be answered in seconds with a search engine, where impatience is rewarded and speed is valued. But the stars do not move quickly. They do not reveal their secrets in an instant. They require patience. They require the long view. And there's something calming in that. The stars do not ask us to hurry. They do not demand our attention. They simply glow night after night, and if we watch them long enough, carefully enough, they show us their motion, slowly, gently, in their own time. The constellations are human inventions. The stars themselves are scattered randomly through space, at vastly different distances from us, with no connection to each other except in our perception. We see them projected onto the dome of the sky, and we connect them into patterns, animals, heroes, objects, stories. Different cultures have seen different patterns in the same stars. The ancient Greeks saw Orion as a hunter, but in ancient China the same stars were part of different constellations, mapped into different stories. In ancient Egypt, some of the stars we think of as part of Orion were seen as the soul of Osiris. In Aboriginal Australia, the dark spaces between the stars, the patches where no bright stars shine, were often more important than the stars themselves, forming shapes like the emu in the sky. The patterns are not in the stars, they are in us. They are the way we make sense of the vastness above us, the way we impose order and meaning on the random scattering of lights. And because the patterns are human, they change. Not because the stars change, but because cultures change, languages change, stories change. But even though the patterns are human, the stars themselves remain. They are the same stars, whether we call them Orion or something else, whether we see a hunter or a soul or an emu. The lights are there, glowing in the dark, and we can arrange them however we like. And yet, there is a persistence to the patterns. The constellations we use today, the ones with Latin names like Ursa Major and Cassiopeia and Scorpius, are based on patterns that go back thousands of years. Some of them can be traced to ancient Mesopotamia, to the Babylonians and Sumerians, who mapped the sky and gave names to the patterns they saw. These patterns have been passed down through generations, through cultures adapted and changed but still recognizable. The Big Dipper has been seen as a dipper, a plough, a wagon, a bear, depending on the culture. But the pattern itself, the 7 bright stars in that distinctive shape, has been recognized for thousands of years. And the reason the patterns persist is because they are useful. They help us navigate, they help us tell stories, they help us remember where things are in the sky. Constellations are a kind of map, a way of organizing the chaos of stars into something manageable, something memorable. But the map is changing, slowly. The stars are drifting, and over tens of thousands of years the constellations will lose their shapes. The Big Dipper will no longer look like a dipper. Orion will no longer look like a hunter. The patterns we know will dissolve, and new patterns will emerge, or perhaps no patterns at all, just a random scattering of lights with no familiar shapes, but that is far in the future. For now, the constellations are still recognizable. They are still the patterns seen by ancient peoples, and they will remain so for many generations to come. To lie beneath the stars and trace the patterns, to connect the dots in your mind, to see the hunter or the bear or the dipper, is to participate in something ancient, a human tradition that spans cultures and millennia. It is a way of making the universe feel smaller, more manageable, more connected to us. And there is comfort in that. The stars are vast and distant, but the patterns are ours. They belong to us. They are the way we make sense of the night sky, the way we bring order to the chaos, the way we tell stories about the lights above us. The motion of the stars is not something we can see with our eyes alone, not in a single night, or even in a single lifetime. It requires instruments, measurements, the careful recording of positions over long periods of time, and it requires patience, the willingness to wait for the motion to reveal itself. Ancient astronomers used simple tools, sighting sticks, plumb lines, stone circles aligned with the rising and setting of certain stars or the sun at certain times of year. Stonehenge, for example, is aligned with the summer solstice, the longest day of the year. On that day, the sun rises directly over the heel stone, a large stone outside the main circle, and its light floods into the center of the monument. This alignment is not random. It was carefully constructed over generations by people who watched the sky and understood the cycles of the sun. They knew that the sun rises in slightly different places on the horizon throughout the year, reaching its northernmost point on the summer solstice and its southernmost point on the winter solstice. And they built Stonehenge to mark those moments, to create a calendar in stone. But Stonehenge is more than 4,000 years old, and in that time the Earth's axis has wobbled. The alignment is no longer perfect. The sun does not rise exactly over the heel stone on the summer solstice anymore. It rises slightly to the side a few degrees off. This is because of precession. The Earth's axis has shifted, and the position of the sun relative to the stars has changed. The people who built Stonehenge did not know about precession. They could not predict that the alignment would drift, but it did. And today, when archaeologists and astronomers study Stonehenge, they use the misalignment to help date the monument, to figure out when it was built, because the amount of drift tells us how much time has passed since the alignment was perfect. This is one way we can see the motion of the stars. Not by watching them move, but by looking at the records left behind by ancient peoples and seeing how those records no longer match the current sky. The pyramids of Egypt, for example, are aligned with incredible precision to the cardinal directions: north, south, east, and west. And they are also aligned with certain stars, including Thuban, which was the pole star when the pyramids were built. Today, Thuban is no longer the pole star. It has drifted away from the pole, and Polaris has taken its place. But the pyramids still point toward where Thuban was, frozen in stone, a record of the sky as it appeared more than 4,000 years ago. These alignments, these ancient monuments, are like time capsules. They preserve a snapshot of the sky at a particular moment in history, and by comparing that snapshot with the current sky, we can measure the motion of the stars, the drift of the pole, the effects of precession. It is a kind of archaeology of the sky. We study the past not just by digging in the ground or by looking up, by comparing what we see now with what ancient people saw and measuring the difference. And what we find is that the sky has changed. Not dramatically, not in ways that would be obvious to a casual observer, but measurably, precisely. The pole has drifted, the equinoxes have shifted, the stars have moved very slightly in their slow dance through the galaxy. This motion is written into the fabric of the universe. It is part of the natural rhythm of the Earth and the stars, a rhythm that plays out over thousands of years but leaves traces we can see, if we know where to look. Today we have much more precise tools. Satellites that can measure the positions of stars to within thousandths of a degree. Atomic clocks that can measure time to within billionths of a second. Computers that can simulate the motion of the Earth and the stars with incredible accuracy, predicting where they will be thousands of years into the future, or calculating where they were thousands of years in the past. These tools allow us to see the motion of the stars in ways that ancient astronomers could never have imagined. We can watch the wobble of the Earth's axis in real time. We can measure the proper motion of individual stars, tracking their paths through the galaxy. We can even detect the tiny shifts in the Earth's rotation caused by earthquakes, by the melting of glaciers, by the slow redistribution of mass across the planet's surface. But even with all these tools, the experience of the night sky remains the same. When you lie beneath the stars, they do not feel like they are moving. They feel still, eternal, unchanging. And that is because the motion is so slow, so gradual, that it exists on a timescale beyond our direct perception. We can measure it, we can calculate it. We can see it in the records of the past and the predictions of the future. But we cannot see it with our eyes alone in the present moment. The stars are patient. They move at their own pace, unhurried, unconcerned with our brief lifetimes. And there is a kind of peace in that. The universe does not rush. It does not demand our attention. It simply unfolds, slowly and gently, at its own speed. The Earth rotates smoothly, once every 24 hours. And this rotation is so constant that we use it to define time itself. The length of a day, the turning of the clock, the rhythm of our lives, all of it is tied to the rotation of the Earth. But the Earth's rotation is not perfectly constant. It is slowing down very gradually due to the gravitational pull of the Moon. The Moon's gravity creates tides in the Earth's oceans, and as the water sloshes back and forth, it creates friction, a drag on the Earth's rotation. This friction is very small, but over millions of years it adds up. The Earth is spinning more slowly today than it was in the past. A day is getting longer by about 2 milliseconds per century. That is a tiny amount, imperceptible in a single human lifetime, but measurable over long periods of time. Hundreds of millions of years ago, when the dinosaurs walked the Earth, a day was shorter, only about 23 hours. And billions of years from now, if the Earth is still here, a day will be longer still, perhaps as long as 50 hours or more. This slowing is part of the same gravitational dance that causes the Moon to drift slowly away from the Earth. As the Earth's rotation slows, the Moon's orbit grows larger. The Moon is moving away from us at about 3.5 centimeters per year, a tiny amount but real, measurable, and part of the long, slow evolution of the Earth-Moon system. This means that the Moon, which seems so constant, so unchanging, is actually drifting away, very slowly. In the far future, it will be farther from the Earth, and it will appear smaller in the sky. Solar eclipses, where the Moon perfectly covers the Sun, will no longer be possible because the Moon will be too far away, too small to fully block the Sun's light. But that is billions of years in the future. For now, the Moon is still close enough to create the eclipses we see, still close enough to raise the tides, still close enough to slow the Earth's rotation just a little, year by year. These changes, these slow evolutions, are part of the natural rhythm of the solar system. Nothing is truly fixed. Everything is in motion, even the things that seem most stable, most constant. The Earth's rotation, the Moon's orbit, the tilt of the axis, all of it is changing very slowly but undeniably. And this is true of the stars as well. They are not fixed in place. They are moving, orbiting the center of the galaxy, drifting through space, slowly changing the patterns we see. The sky we know is just one moment in a much longer story. A story that began billions of years ago and will continue for billions of years to come. To know this is to feel the depth of time, the kind of time that makes human history feel brief, that makes our own lives feel like a single heartbeat in the long life of the universe. And yet, we are here, in this moment, witnessing this configuration of stars, this particular view of the sky. And that is enough. The stars have names, many of them ancient, passed down through languages and cultures. Sirius, Betelgeuse, Rigel, Arcturus, Vega. These names carry history, stories, meanings that have been layered over the centuries. Sirius, the brightest star in the sky, comes from the Greek word meaning scorching, because it rises in the heat of summer. The ancient Egyptians called it Sopdet, and its rising marked the flooding of the Nile. In many cultures, Sirius has been associated with heat, with fire, with the intense days of late summer, sometimes called the dog days, because Sirius is the brightest star in the constellation Canis Major, the great dog. Betelgeuse, the red giant in Orion, has a name that may come from Arabic, possibly meaning hand of the central one, though the etymology is uncertain. It is a star that ancient peoples noticed because of its color, a deep orange-red that stands out against the blue-white stars around it. Rigel, the bright blue star marking Orion's foot, also comes from Arabic, meaning foot. Arcturus, the bright orange star in boots, comes from Greek, meaning guardian of the bear, because it appears to follow the constellation Ursa Major, the great bear, across the sky. These names are human. They are the way we label the stars, the way we remember them, the way we tell them apart. But the stars themselves do not have names. They are just stars. Glowing balls of gas and plasma fusing hydrogen into helium, shining across the vastness of space. The names we give them are for us. They help us navigate the sky. They help us tell stories. They connect us to the past, to the people who first looked up and named these lights. And as the stars drift, as the constellations change shape, the names may drift as well. Some names may be forgotten, others may be applied to new stars as old ones fade or move away. The sky is not static, and neither is the language we use to describe it. But for now, the names remain. Sirius is still Sirius. Betelgeuse is still Betelgeuse. And when you look up and see these stars, you are seeing the same lights that ancient people saw, and calling them by names that have echoed through centuries. There is a continuity in this, a thread that connects us to the past. When you say the name Sirius, you are speaking a word that has been spoken for thousands of years, in different languages by different peoples, but always referring to the same star, the brightest point of light in the night sky. And this continuity is part of what makes the stars feel eternal. They are not just distant lights, they are part of human history, part of our stories, part of the way we understand the universe. The stars are so far away that their light takes years to reach us, and this means that when we look at the stars, we are looking into the past. But it also means something else. It means that the stars we see are, in a sense, already gone. Not gone in the sense of having ceased to exist, but gone in the sense that they have moved on. The light we see tonight left those stars years ago, and in the time it has taken the light to reach us, the stars themselves have continued on their journeys through space. This creates a strange kind of disconnect. The star is not where it appears to be. It has moved slightly, and the light we see is showing us where it was, not where it is. For nearby stars, this difference is small. For distant stars, it can be larger. But the effect is subtle, and for most purposes, it does not matter. The stars appear where they appear, and that is where we see them. The fact that they have moved slightly in the time it took their light to reach us is interesting, but it does not change the experience of looking up and seeing them. It is just one more layer of the strangeness of the universe, one more reminder that the sky we see is not a snapshot of the present, but a tapestry woven from many different moments in time, each star showing us a different slice of the past. And this tapestry is always changing. New light is always arriving, bringing us new images of the stars as they were moments ago, or years ago, or centuries ago. The sky is not static. It is a constantly updating picture of the universe, shaped by the speed of light and the motion of the stars. To lie beneath the stars and think about this is to feel the strangeness of time and distance. The stars are here but also not here. They are now but also then. They are close but also impossibly far. And all of these contradictions are held together by the light that travels across space, bringing us messages from distant suns. The stars are not just lights, they are connections, threads that link us to the universe, to the past, to the vast distances of space. And when we look up, we are not just seeing lights, we are receiving messages, photons that have traveled across years or centuries to reach our eyes, carrying information about distant places, distant times. Each photon is a tiny messenger, a quantum of light that began its journey long ago, and has finally arrived here now to be absorbed by your eye, to create a signal in your brain, to become part of your experience of the night sky. And there is something beautiful in that. The universe is not silent. It is constantly sending us messages in the form of light, and when we look up, we are reading those messages, decoding them, understanding them, even if we do not always think about it that way. The stars speak to us not in words but in light, and we listen not with our ears but with our eyes. And what we hear or see is the story of the universe, told in the slow drift of constellations, the patient turning of the earth, the ancient light of distant suns. There is a rhythm to the night sky that mirrors the rhythms of our own lives, the daily rising and setting of the stars, the monthly cycle of the moon, the yearly turning of the seasons. These rhythms are larger than us, older than us, but they shape our experience of time in ways we do not always notice. The stars rise and set, and we call this a day. The moon waxes and wanes, and we call this a month. The sun moves through the zodiac, and we call this a year. These are the natural units of time, the cycles given to us by the sky, And for most of human history, they were the only clocks we had. Before artificial light, before electric clocks, before schedules and calendars, people lived by the sky. They woke with the sun. They slept under the stars. They planted and harvested according to the seasons, marked by the positions of the sun and the stars. The sky was not just something to look at, it was something to live by, a guide, a calendar, a clock. And though we have artificial light now, though we have clocks that do not depend on the sun or the stars, the rhythms are still there. The earth still turns, the moon still orbits, the sun still moves through the seasons, and the stars still rise and set night after night in the same patient patterns. To lie beneath the stars is to reconnect with, to lie beneath the stars is to reconnect with that older sense of time, the kind of time that does not rush or demand, the kind that unfolds whether anyone is watching or not. When you look up at the night sky, you are seeing motion that is so slow it feels like stillness, change that happens on a scale far beyond a single night, or even a single lifetime. And yet, that motion is constant, dependable, never hurried. The stars you see tonight will be there tomorrow night, and the night after that, rising a little earlier, setting a little farther west, shifting almost imperceptibly as the Earth continues its quiet spin. Over months and years, constellations trade places with the seasons. Over centuries, their shapes slowly stretch and drift. Over thousands of years, even the orientation of the sky itself changes, guided by the gentle wobble of our planet's axis. None of this happens quickly. None of it needs attention to continue. It simply unfolds. There is comfort in knowing that these rhythms do not respond to our stress or our urgency. The stars do not speed up when we are anxious. They do not pause when we are tired. They move at the same unhurried pace they always have, indifferent to human schedules, untouched by our worries. In that sense, the night sky offers a kind of permission to slow down, permission to stop measuring every moment, permission to rest. When you allow your attention to drift upward, when you imagine the earth turning beneath you and the stars appearing to glide across the sky, your own inner rhythms can begin to soften in response. Your breathing can slow, your thoughts can loosen their grip. The nervous system, so often tuned to urgency and alertness, can begin to take its cues from something older and steadier. This is one of the quiet gifts of the night sky. It reminds us that time does not have to feel sharp or demanding. Time can be circular, time can be gentle, time can be something you move within, rather than something that chases you. As you lie here now, perhaps with your eyes closed, perhaps imagining the slow arc of stars above you, you are still part of these rhythms, whether you notice them or not. The earth is turning beneath you. The sky is shifting overhead. The same motions that guided ancient travelers and early farmers are still happening, still marking the passage of night. And just as the stars rise and set without effort, sleep too is something that arrives when it is allowed to. You do not need to force it. You do not need to watch the clock. You can simply rest in this moment, breathing slowly, letting your body follow the older rhythm it already knows. The stars will continue their calm movement through the sky. The night will continue to unfold, and you can allow yourself to drift with it gently, patiently into rest.